Okay, this is question one. Free response AP problem says airlines routinely overbook flights because they expect a certain number of no-shows. An airline runs a 5 p.m. commuter flight from Washington, D.C. to New York City on a plane that holds 38 passengers. So the plane will hold 38 passengers. Past experience has shown that if 41 tickets are sold for the flight, then we have a probability distribution for the number who actually show up. So they are selling 41 tickets for a 31 passenger flight. This is similar to a problem we had done before. There are 38 passenger seats on the flight. What is the probability that all passengers who show up will get a seat? So for all to show up to get a seat, that means that only 38 or less had to show up, because if more than 38 showed up, then they would not get a seat. Because if 39 showed up, one person would be without a seat. If 40 showed up, two people would be without a seat. 41 showed up, three people would be without a seat. So we're looking at just when 36, 37, or 38 people showed up, and it gives us those probabilities. That's 0.46 plus 0.30 plus 0.16, and that adds up to 0.92. So the probability that all passengers who show up will get a seat is 0.92, or 92% of the time, and you would have to show your work how you got that number. What is the expected number of no-shows for the flight? Well, we can do the expected number of people who will show up, and that is 36 times 0.46 plus 37 times 0.30 plus 38 times 0.16 plus 39 times 0.05 plus 40 times 0.02 plus 41 times 0.01. That will give us our expected number of people to show up. Okay, so 36 times 0.4, and you can go put that in the calculator and get the answer here. And you get a total of 34.74. Oh man, I messed up on one. Not 34.74. Let me go back. Second enter. I caught my error there. 41 times 0.01, 40 times 0.02, 39 times 0.05, 38 times 0.16, 37 times 0.3, 36 times 0.46. I had 0.4. Okay. Now, 36.9 is your expected value. To get an expected number of people show up, 36.9, you sold 41 tickets. So how many are you expecting not to show up? That would be 41 tickets sold minus 36.9 that show up, gives you about 4.1 no-shows that you would expect per flight. Now, part C says, given that not all passenger seats are filled on a flight. So we'll say we are given that not all of them are filled on a flight. Then what happens? What is the probability that only 36 showed up? So, given that not all passenger seats are filled. So if we look, if the plane holds 38, then 38 would mean it's filled if 38 show up. If 39 show up, it's filled and one person's not there. 40 show up, it's filled and two aren't there. And if 41 show up, it's filled and three are not on it. So we're only dealing with passenger seats not filled. So that would be 36 and 37. Those probabilities add up to 0.76. And it says, what's the probability that only 36 showed up? That's 0.46. So 0.46 over 0.76 will give us the probability that, given that we knew the seats weren't filled, so that means less than 38 people showed up, what's the probability that it was actually 36 people that showed up? And that would be 0.605, or a little over 60%. So a little over 60% chance that 36 people showed up, given that not all the seats were filled. Again, you have a E, which means you got every part of it. You would need all that in A, B, and C to get it. You also need to explain what you're doing in words as you're doing it. P is partial, and then I is incorrect. You add those up. To get a 4, you would need all 3 essential. To get a 3, you would need 2 essential, 1 partial. To get a 2, you would need at least all partial, and then get a 1, you're going to have some incorrects on that one. So we'll move on to the next question. The next question is Chapter 8, Frappy. These are on the back. It says, every Monday, a local radio station gives coupons away to 50 people who correctly answer a question about a news fact from the previous day's newspaper. The coupons are given away are numbered 1 to 50. So you have coupons that are numbered 1 through 50. And the first person receives coupon 1, the second person receives coupon 2, until all 50 coupons are given away. On the following Saturday, the radio station randomly draws numbers from 1 to 50 and awards cash prizes to the holders of the coupons with these numbers. Numbers continue to be drawn without replacement until the total amount awarded first equals or exceeds $300. If selected, coupons 1 through 5 have a cash value of $200. So 1 through 5, their cash value is $200. Okay. It says coupons 6 through 20 have a cash value of $100. And coupons 21 through 50 have a cash value of $50. Explain how you would conduct a simulation using the random number table provided to estimate the distribution of the number of prize winners each week. Okay, so the simulation you're going to use here is you are going to use random digits from 01 to 50, and we're going to go by 2-digit numbers. 1 through 5 is going to count as $200, 6 through 20 would be $100, 21 through 50 would be $50. Now you have to explain your steps here, but let's just say we have a random number or random digit table, and I'm just making up some numbers. And of course, this isn't random, but it would be. Let's say I want to pick the numbers that I have here. So the first one would be 23, okay? And the number 23 means I got $50 so far, okay? The next number I would get is 56, which doesn't count. Then 89, which doesn't count. Then I get 01 is my next number, and that would mean $200 so far. And remember, I can give out $300, and then I have to stop. So I go to the next one, it's 72. 72 is not in our sample. Then I go to the next one, it's 36. And 36 is worth $50. And if you add up now, I've given out $300 in this simulation. So now I would have to repeat it the next time, okay, to see what happened. So I'm using random digits. I'm going from 0, 1 to 50. I don't know how many I'm going to do. I'm just going to do as many as I can until it gets up to $300, because that's how many it said, how much money it says for that problem. That's your simulation. So in this week, there were actually 3 prize winners because one person got $200. If all of them drawn were $50 ones, then you could have up to 6 prize winners. But you'll never have more than 6, because that's impossible. And you'll never have less than 2, because 1 will only get you to 200, and you have to get to 300 before they stop. All right. Explain, so part B, perform your simulation 3 times. So at the bottom, start at the leftmost digit. So in A, you needed to explain this process. And now in B, we're performing the simulation 3 times and seeing what happens. Now, when I work it out the first time, I get 72, 74, 91, 33 is the first one I have, and that adds up to $50. This is my first simulation. Then the next time, I get 47. That's $50 more. 65 is not in there. Then I get 03. That's $200. And so I'm done. I reached my $300 total, so I'm done. That's simulation 1. Simulation 2, I'll start at the second line. I get 81, 63, 83, 65, 66, 42, which is $50. 70, 93, 37, which is $50. 17, which is $100. 59, 94, 31, which is $50. Now I'm at 250, and then 20 would be my last one, and 20 is $100. So I ended up giving out $350 that week. I ended up giving out 5 prizes in my second simulation. In my third simulation, start at the third line, I get 38, which is $50. I got 44, which is $50. 94, which is not our sample. 64 is not our sample. 38, again, which we can't do because that person's already won. 91, 57, 90, 19, which is $100. And then I get 07, which is $100. And I'm at my $300. So if you notice, the first simulation, 3 people were selected. In the second simulation, 5 winners were selected. In the third simulation, 4 winners were selected. So in each one, it says report the number of winners in your trials. That's what we just did right there. That's how many winners were selected in each one. All right, so we go to 2003. The following problem, it says, is from AP exam. Men's shirt sizes are determined by their neck sizes. Suppose that men's neck sizes are approximately normal with a mean of 15.7. So we know the mean is 15.7 inches, and the standard deviation is 0.7 inches. Okay. A retailer sells men's shirts in sizes small, medium, large, and extra large, where the shirt sizes are in the table below. All right, part A. Because the retailer only stocks the sizes listed above, what proportion of customers will find that the retailer does not carry any shirts in their size? So that would be those that are less than 14, and then those that are more than 18. So if you want to think about it in part A, those that are less than 14 are lower of -999, upper of 14. Now it's going to be less than 14. We already know what the mean is. The mean is 15.7, and the standard deviation is 0.7. So that will tell you how many people will not have it in their size because their neck is too small. Okay, and now the other part will tell you how many people won't find the shirt in their size because their neck is too big. So if you think about their neck being too big, it's going to be those that have a neck that's higher than 18. So their neck is bigger than 18. So it's going to be 18 all the way up to 999. So what percent of people have their neck is too small? So do a normal CDF, -999 to 14. 15.7 is our mean. 0.7 is our standard deviation. And we get 0.0075. I'm going to put 0.0076 to round it for this one. And then over here, when I use 18 all the way up to 999 and look at the people with their neck size bigger, actually on that one I get e to the -4th, which means 0.000, and then the fourth one is a 5. Now, the question asks, which ones will not have shirts in their sizes? So if I add them together, it'll be, now these are because it's too small, these are because it's too big. If I add those two numbers together, 0.0076 plus 0.0005, I'm going to get 0.0081. Okay? So now what is that? That's less than 1% of people. So 0.8%. So it's less than 1% of people that would not find a shirt in their size. So I think they're doing pretty good for themselves. Now, using a sketch of the normal curve, illustrate the proportion of men whose shirt size is medium, and then it says calculate this proportion. I want to see the men with a shirt size of medium and calculate it. So I'm going to draw the normal curve for this problem. It's been a while since we've done that. 15.7 is in the middle. Each standard deviation is to the left and to the right, and it goes by 0.7. So this is 16.4. This is 17.1. Okay, this is 17.8. This is 15. This is 14.3. Oops. The mouse is going crazy here. Should be fine. Okay, that's 14.3, and then that's 13.6. So now, what it wanted to see is where's the medium ones at. That's from 15 to 16. So on the curve, 16 is probably somewhere in here. We know where 15 is. It's right here. So from 15 to 16 is this area on the curve. Now, it says sketch it. Using a sketch of a normal curve, illustrate the proportion of men whose shirt size is medium. Now it says actually calculate this proportion. Very simple for B. What is the lowest it can be? 15. What is the highest it can be? 16. What is the mean? 15.7. What is the standard deviation? 0.7. So again, find what proportion that is with your normal CDF. Normal CDF really gets you through a lot of stuff. And you get 0.507. It's over 50% there. From 15 to 16, you have over 50%. And if you think about it, this is 30%, or this is, you know how it goes, 34, 34. These are 34% blocks, and you have all of this block, which is 34%, and then you've got part of this. So you end up getting a little bit over 50%, okay, total with a medium. Part C now says, of 12 randomly selected customers, what is the probability that exactly 4 will request a size medium? Now we know how many have a 4, 0.507. So that's how many are, or we know how many have mediums. A little over 50% of our customers are mediums. So what's the probability that exactly 4 will request a medium? Either they request a medium or they don't. So we got a binomial here, kind of. On part C, think binomial, because it's either they request a medium or they don't. PDF, how many people? 12. What's the probability of getting a medium? 0.507, because that's how many have mediums. And then, how many do we want? Exactly 4 to get a medium. So, I go to my calculator. I look for binomial PDF. It's in second distribution. And 12 trials, 0.507 is my probability, and I want exactly 4. And the probability of exactly 4 out of 12 people wanting a medium shirt is 0.1141. So a little bit over 11% chance that 12 people will walk into the store and 4 of them will want to get a medium shirt, and that's because they wear a medium size. Okay, so hopefully that takes you through these problems. These problems, we're going to drill these through the end of the semester because our goal is to destroy the AP exam. Okay, so that's our goal, and that's what we're going to try to do and get through. So if you're struggling now, just think, you really know a lot more than a lot of people, I think, in a lot of different classes, even throughout the country. I think you guys are really going to be very well prepared for this. So we'll keep rolling, and hopefully you understood these, worked these out at home, and it wasn't too much trouble for you for me to spend the time to go over them. And next on our list, at the end of the semester, we're going to move now to confidence intervals.